Okay, so this is the question. Let us go through the question carefully. Martin, he solved 24 mathematics questions in 2 hours. Okay, calculate the number of questions which can be solved by Martin within 235 minutes. So solve this problem through mathematical modeling. Okay, he is able to solve 24 questions in 2 hours. That's a long time. So they were asking in 235 minutes how much question he can solve. So you need to change them to the same unit. 2 hours is 120 unit. 35 minutes, how much is the time in hour? Okay, first identify the problem. Make it bigger. For identifying and defining the problem, you need to determine the number of questions which can be solved in 235 minutes. So we know that the more the time taken, the more mathematics question can be solved. Thus, the number of questions varies directly as the time. So this one varies directly, meaning we are going to have a linear graph. Okay, for making assumptions and identifying the variables, first we assume that the difficulty level of all the mathematics questions is the same. Meaning there is no hot question or there is no higher level question. And then Martin does not have any problems in solving mathematics question. No problem means he understands all the syllabus very well. Okay, he didn't stuck. And then we are going to identify the variable now. Let t be the time taken in minutes and n be the number of mathematics question that he can solve. So this one just now is 24 questions he can solve in 2 hours. So we need to determine the time taken for 235 minutes here. How many number of questions can be solved? So n varies directly as t. Hence n equal to kt, where k is a constant. Okay. So this one you learned in chapter 1 already. That is direct variation. Now we look at applying mathematics to solve problems. So over here we are going to substitute all the value that is given from the information. So substitute t equal to 120 and n equal to 24. This is 24 questions in 120 minutes into this to get the value of the constant. So the value of constant is 1/5. Okay, after that you just substitute into the equation, this one. Hence you are going to get n equal to 1/5t. So this question describes the relationship between the number of mathematics questions which can be solved with the time. So when the t is 235 minutes, so what do we do is we are going to apply the formula that we get just now, n equal to 1/5. You just multiply with the time. So he is going to get 47 questions. Hence, 47 mathematics questions can be solved by Martin in 235 minutes. So after that, you are going to get this. Verifying and interpreting solutions in the context of the problem. So the linear function n equal to 1/5t obtained may not be used in all question solving situation because the difficulty level of mathematics questions are not the same. Okay, and then Martin may need to take some time to understand and solving a more difficult mathematics question, and he may take a shorter time to solve an easier mathematics question. Okay, when this is reflected to the real world situation, the linear function model obtained, this one don't have, is not suitable to solve this problem. So just now, Isa's group also, they have their own verifying and interpreting solutions, which is very good. So all the mathematical modeling over here, it actually varies. It depends on how you give your explanation. Okay, so on this part, refining the mathematical model in this problem, we are not able to refine the model due to limited information given. So that's all. You don't have to further add on with the reporting findings. Okay, so for the next question, this one, do you have any problem for this question? Any problem?
No problem.
No problem, huh?
No problem.
Okay. So for the next one, this is number 4 here. I repeat again this question so that you understand better on what is all about in this question. So you look at number 4 here. The diagram on the right shows a suspension bridge. The shortest distance from the main cable to the deck is 5 meters. Let us look at the deck. This is the deck. Can you see the one in gray here? This is the deck. They show it using the arrow. So they gave you the information that the shortest distance from the main cable to the deck is 5 meters. The shortest one, of course, is this one. Okay, the one in the middle. So they show you the main cable over here, which means the length over here is 5 meters. Okay, so the rest, of course, is not 5 meters. It will be longer one by one. You can see over here. Now, this part is the concrete tower. So all of this, they call it the suspender cable. All of this, including the main cable over here. All the suspender cable. We don't know how many of it. And then the height of the concrete tower here is 35 meters. The length of the bridge, okay, from the concrete tower to the other end here, it is 600 meters. Now, look at the question now. Show how an engineer can use the information given to solve the following problems through mathematical modeling. So you need to show it how to solve it. A. Determine the function that represents the arc of the main cable. So in the previous group, Amir's group, and also which group just now? Rushdina's group. They are using the ax squared plus c. So over here, I'm going to apply what you have learned now. We have two different methods to solve it. This is the first one here for A. So we assume the bridge looks like this in a graph. Okay, all of these are positive value. 0, 35, 305. 300, this is the value of the x. This is y. So just now they told you the main cable is 5 meters, right? That's why it is 300 with a 5 over here. And then this one is 635. Why 35? Because of the height of the concrete tower. It is 35. You see this one? This is 35. This is 35. Okay, so in the middle, of course, 600 divided by 2, this is 300. That's why I have a quadratic graph like this, 300. Because 600 divided by 2, we get a 300. With the shortest cable here, that is 5. And then the rest, it will follow the value of the end of it. This is 600 with the height of the concrete tower, 35. And then this is 0. The height of the concrete tower is 35. Okay, understand, class?
Yes.
Yes,
Yes.
So, from here, we are going to determine the related quadratic function of the form y equal to ax squared plus bx plus c. This is the one that you have learned in the first chapter of Form 4. So, we are going to determine the consonant A, or the constant A, B, and also C here by substituting the value of the coordinate given, 0, 35, 305, and 635. So if we substitute 0, 35 into the equation, the value of y is 35. So we will have y, 35, equal to a, x is 0, bx, 0, plus c. Finally, the c is just going to be equal to 35. So this is the first equation. Okay, we are going to use the substitution method to solve everything. Same thing for the second point here, 305. You substitute everything, we are going to get this second equation. And then the third point, 635, we are going to substitute everything into this equation. So you are going to get this. After that, you are just going to solve everything using the substitution method. You see, substitute the first one, the c into 2. So the c over here will be 35. That's why I change everything the other way around. 90,000 A plus the 300B plus the C. C is 35 from here. So plus 35 equal to 5. Okay. So after that, 90,000 A from here, I bring all the rest to the right. I'm going to get negative 30 minus 300B. Negative 30 because 5 minus 35. I get a negative 30. So after that, I factorize it. Therefore, I find the subject A. It is negative 30. and then in bracket 1 plus 10b over 90,000. So then I simplify this with the 90,000, I'll get this one. Therefore, A is equal to negative times 1, negative 1, negative times 10 here, negative 10b over 3,000. So this is the fourth equation. I'm going to substitute the fourth equation into the third equation, this one. For what? To get the value of the B. So I'm going to substitute the A over here into this A. I change it the other way around now. I just exchange the position here. So 360,000 A, 360,000 A. This is the A that we get just now. Plus 600B plus 35 from here. 600B plus 35 is the C, is equal to 35. So we solve everything again. Okay, solve everything again from here. I make it bigger. You do the calculation, do the calculation, everything. We are going to get the value of the B is equal to negative 1 over 15. After you simplify everything, you can try this out on your own. Try to go through all of this and try out on your own. Later on, after I give you the video, you also can refer. So this will be the fifth equation. We get the value of B already. So lastly, substitute this into the A so that we can get the general equation. So when I substitute into the A over here, the value of B of negative 1 over 15, this is the one. You solve it, you are going to get the value of A is 1 over 3,000. So we are going to get the mathematical model for this one is y equal to 1 over 3,000 x squared minus 1 over 5x plus 35. This is according to this function, this one. So you can see actually not all the equation that we generate is fixed. It depends on how you solve it. So for this one, my mathematical model is y equal to 1 over 3,000 x squared minus 1 over 5x plus 35. You remember this one? So it depends as long as your flow of solving is correct. Nothing wrong if you can get different mathematical model. Every of the group or each of the group that solve a same problem, they might come out with a different mathematical model. You have to think in that way. Not all the mathematical model will be the same, as long as it can be used. Okay, so this is one of it, the mathematical model. Now I show you another one. Okay, on not this anymore. You see this one, everything is positive. So if according to the next one here that I'm going to show you, this one will consist of a positive and a negative. Can you see? This is the bridge, 600 meter. This is the concrete tower. So if I put the Y in the middle, that is the main cable of 5 meter over here, meaning to the left over here, it will be negative. This one is positive. You just assume it's on your graph like this. So it's this way right now. Okay, therefore the first point that I'm going to get is negative 335, this point here. It becomes a negative now. And then the one in the middle is 0, 5. And the right here is 305. Why 300? Because the 600 divided by 2. This part is a 0. This is 300. Negative 300. Are you okay so far?
Yes.
Yes, So same thing, we are going to make the substitution into y equal to ax squared plus bx plus c. You see, y equal to ax squared plus bx plus c. So the y is 35, this one, and then the x is negative 300. So I substitute the x into this and also this. Okay, same thing for the second one, also we solve it that way, and for the third one. So we are going to do all the substitution method. You just solve everything, find out the value of A. After that, substitute the A into the next equation to get the value of B. So from here, this is the A, substitute the B, and you are going to get the A. Finally, the A is equal to 1 over 3,000. Maybe I forgot to write down the A here. A. Okay, so we are going to get another mathematical model for this one, which is y equal to 1 over 3,000 x squared plus 5. So it's different from the first one. The first one, because we are using the first quadrant, all the positive value of the graph. But for this one, we are using the both sides, the first and the second quadrant. That's why we will generate this mathematical model. But they are the same. When you apply the number into it, you still get the correct answer. Okay? So the graph is a quadratic function that allows to calculate the length of the suspender cable. Okay, regarding the second question, okay, we go through the second question first. This one is the one that Shauki was asking the group just now. Okay, this is the question here. So first one, we already found out the function. It can be the first one or the second one, up to you how you want to solve it. Okay, so for B, if the suspender cables are 20 meters apart, means this suspender cable here, the length here, 20 meters apart. Each of this distance of the suspender cable is 20 meters apart. So what do they want? Let's see. If the suspender cables are 20 meters apart, determine the number of suspender cables needed on both sides of the bridge. So you need to determine how many suspender cable over here is needed on both sides. This is one side, this is another side. How much is the total of this blue colored suspender cable is needed? Okay, so I make something like example for you. Before we go through on how to find the number of suspender cable first. For example, if I have a 100 meter length of a string, I want to divide 10 meter. Okay, so when I divide by 10, meaning that I divide by 10 parts, right? You can see this is 1, 2, I don't know whether you can see or not. Okay, this is 1 part, 2 part, 3, 4, 5, 6, 7, 8, 9, 10. 10 parts, right? 100 meter divided by 10 parts. So it's different thing when it comes to suspender cable. You are going to count the line. You see the line over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we will have 11 over here. That's why we have to minus 1 to get 10 parts. You understand what I mean? That's why over here, for the length of the bridge, we have 600. We divide by 20 meters, but then we have to minus 1 over there. Okay, to make it accurate. Now, why we times 2? We times 2 because we want to get both sides. Then you are going to get 29 times 2. So the total number of suspender cable is 58. Are you okay for the calculation on this part here?
Yes, madam. Yes, madam.
Yes, Okay, so and one more thing, I just noticed when I go through the slide for Amel's group, I think they do like this 2 times 600 over 20 and minus 1. Okay, so you check back, this one is not correct. Actually, we have to minus 1 first. Only then we multiply by 2 to get both sides. Okay, now, the third one, I think none of the group, you get the correct answer. You only show me how to get the correct answer at the back, the total cost over here. So we look at this question, the last one here. Determine the type of material that should be used to make the suspender cables such that the total cost of the cable is minimum. They want the least amount of cost to build the bridge over here. So they give you the different distance over here. The one that we have just now is 20 meters apart, this one. So you will ask also to find out if it is 15 meters apart and also 25 meters apart with the type of different material that we have, type A, type B, type C, and the cost of different of the material. Maybe type C, the material is better. Type A material is not very good, so it is cheaper. We don't know lah, So you will ask to find the total cost of the suspender cable. How to find the total cost of the suspender cable? Of course, you need to find out how much is the total length of the suspender cable that you have and you multiply with the cost. So we need to get the total length. How to get the total length? First, from here, you see, you're given the distance between the suspender cable. For example, this is your suspender cable. Okay, your suspender cable. So, for 15 meter apart, you have to find the number of suspender cable first. How many suspender cable do we need for 15 meter apart? So, we are going to use the same formula that we have just now to get the number of suspender cable needed. This is the formula that we have. Okay, when they say 15 meter apart, you just need to change this to 15. That is for material A. So, if you look at what I have over here, this is material A. If the distance between the suspender cable is 15 meter. So, I write down all of this in detail to let you understand. Position of the suspender cable, the first one. The first one meaning that from the center is 0. That is the one in the middle of your bridge. This one. 0 from the distance of the center. So, for this one, we just need one here and another one on the other side. Meaning that we need 2 of this shortest suspender cable. So, with the length of the suspender cable of 5, that is the minimum one already stated, right? 5, So, we need the total of 10. And then for the second suspender cable, that is 15 meter because they require 15 meter. 15 meter from the center. So from the center over here, we have another 2. But now this time, we need 4. We not only need 2 only. We need 4 right now. So with the length of the suspender cable, 5.1, I'm going to multiply by 4. So I get 20.3. How do I get 5.1, class? How do I get 5.1? The length of the suspender cable. Do you have any idea? Any idea from anyone? How do I get the length of the suspender cable over here? Actually, it's from your calculation. That's why just now you derived the mathematical model, right? You derived this mathematical model. What is the mathematical model? The mathematical model that we have is y equal to 1 over 3000 x squared plus 5. This one. Okay, so how do I get the value of 5.1 is I substitute the value of the x, 15, into the equation here. So I show you if you don't understand. Last. Hold on. This one. Okay, this is the one. So you can see, that's why they said they ask you to use the spreadsheet to show it. This part over here. How do I get it? Because I used 1 over 3000 multiplied by B5. B5, this is cell B5. Okay, that is the distance from the center, 15. Okay, this is to the power of 2 and plus 5. I follow exactly all the formula that we have gotten from here. So we will get 5.1 and so on. You see the rest of it and so on. They substitute the value of the x over here, the 30, substitute. So we will get different length. Of course, we will have different length of the suspension cable, right? Suspender cable. Of course, this is longer to the right. That's why you can see the value of the suspender cable over here is getting longer. It's getting longer. Hold on. You see this one. Because the distance is 0, 15, 30 until 2 at 5 until 300 lah actually, but the 300 is a concrete tower, so we don't need that. Okay, so right hand side 300, left hand side 300. The opposite, another right, another left. So altogether we have to multiply by 4. I just count one part only. How is the one part that I count? Hopefully you understand what do I mean here. This is 2 sides of the bridge, right? 2 sides of the bridge, huh? So I just count one part only. That's why we need to multiply by 1, 2, 3, 4 sides to get the answer. That's why you can see my calculation on the next one. I multiply by 4. This one. Can you see? C5 times 4. I use C5 multiplied by 4 to get the answer. All of this I multiply by 4 except this one. This one because we just need 2. So you have to think carefully. So after that, after I multiply everything, I'm going to get the total length of 1131. Okay, that is how we get the first answer for this part here. Okay, we already have 1131 meter. This part, the total cost of the suspender cable, it is equal to 1131, the total length multiplied by the cost of 1 meter, 750. So 1131 times 750, you are going to get 848250. So it's exactly the same as the one that we have at the back of your textbook. 848250, correct or not? Yeah, 848250. Are you okay so far?
Yes, madam.
Okay, so I carry on with this next one. When it is divided into 20 meter apart with the cost of 1000. So this is the working. When it is divided into 20 meters. If 20 meter, of course, it is shorter because in between the cable, you need to make it longer already. So you don't need that much of cable. So you can see I only have 15 over here, which is from 0, 20, because the distance is 20, up to 280. When it reaches 300, 300 is the concrete tower. So we no need the suspender cable. Okay, so first one, as usual, we just need 2 because that's the shortest cable, one side each. So we will get 10. And the other one, we need 4. So I multiply by 4 over here. So we get 20.5. And continuously, you get the total length of 831.3. So later on, you are going to multiply with the cost to get the total cost. Whereas for material C here, the distance is 25 meter. So you can see I do like this, 0, 25, 50, 75, up to 275. Plus another 25 is 300. 300 is the concrete tower. We don't need it. So again, the first cable, the shortest one, that is the main cable, we only need 2, so we have 10. The rest of the cable, we need 4. Okay, left and right, and the opposite one. So we need 4. I multiply by 4 all of this. I'm going to get this figure. Okay, so let me see whether I have that or not. Don't have. So what do we do is you are going to use 831.3 multiply with the cost. This one. So this will be 831.3 multiplied by 1000 to get the cost of the suspender cable. So you are going to get 831,300. Or if you want to make it more precise, it is actually 831,33333 because over here in my Excel, I make the format into 1 decimal place, as you can see. If I didn't shorten it, it is actually 5.1 something, 5.5 something, 6.2 something. So we will have a total of 831.3333333 actually. Okay, so if you compare with the back of your textbook, I tell you directly, the answer at the back of your textbook is not correct. Do you have your textbook with you right now?
Yes.
Yes, so you turn to page 260. They show the answer at the back of your textbook for this one. It is 831400. Almost I don't know how they round it off to 83140, but the correct one is 831300, or it could be 831333. So you do a correction over there. And then for the next one, this one, for the distance between cable of 25, okay, just now I showed it to you already. The answer is actually, let's see the length again. The length that we have is this one, 651.67. So over here, we have to go back this part. It has to be 651.67 multiplied by 1,200. So calculate again. 651.67 times 1,200. So you are going to get 782,004. 782,000.4 is my answer correct just now? Hold on. 651.67. 651. Sorry, one mistake here. 651.67. 651.67. Okay. 782,004. So it's supposed to be 782,004. Also not correct at the back of your textbook. At the back of your textbook, it shows 781,920. So that two answer is not correct. So you check your answer later on. Okay, for these two. Any question? So we have done the calculation for the last question, which is the hardest one already. Do you have any question else for this question here?
No question.
Okay, no question. So we finished the whole syllabus of your book already. In the next lesson, we are going to do our revision already. Okay, finish everything. Congratulations.